All right, so 12.4 is the addition and complement rules. All right, starts off talking about mutually exclusive events. All right, so mutually exclusive events are events that cannot occur at the same time, or in other words, events that do not have anything in common. All right, so the way you would calculate the probability of mutually exclusive events, you want to know the probability of A or B occurring. You find the probability of A and add it to the probability of B. All right. Before we look at the next example, just want to make sure we're clear on a deck of cards. Let's go. All right, so your standard 52 card deck. Use the word standard to let you know that there are no jokers, in the deck. So there are four suits. We have clubs, spades, hearts, diamonds. Two black suits. In other words, all their cards are black. Clubs and spades, and then all the two red suits, hearts and diamonds. There are 13 cards in each suit. 4 times 13 give you that 52. So in each suit, you have 10 regular cards and 3 face cards. Your 3 face cards are king, queen, and jack. The 10 regular cards are ace, then 2 through 10. All right, questions before we actually get to the problem. All right, suppose a single card is drawn from a standard deck of playing cards. Find the probability of drawing a 5 or a king. All right, so when you look to do this problem, you do want to ask yourself first, are the events mutually exclusive? Or in other words, do they have anything in common? So your answer is yes, they are mutually exclusive. They have no cards in common. So what I mean by that is there's no such thing as a king of fives or a five of kings. If you're a king, you're a king. If you're a five, you're a five. They have no cards in common. So they're mutually exclusive. So that means we can go ahead and look to try to solve. So we want to know the probability, I won't write that part, of drawing a five or a king. Looking at the first event. So we already know there are 52 cards in the deck. So the sample space, the number of our sample space is 52. We have 52 choices. And the number of fives in the deck is 4. There's a 5 in each suit. So the probability of drawing a 5 is going to be 4 over 52. And we can reduce that down later. All right, next one. Talking about drawing a king. Once again, the sample space is 52. The number of kings in the deck is 4. Probability of drawing a king, 4 of 52. So now we're looking at the probability of drawing a 5 or a king. Just add those probabilities together because they do not have anything in common. That'll be 8 over 52. We can reduce by 4. That'll be 2 over 13. All right, questions on that before we go to the next example? All right, so the general addition rule. Before we looked at the addition rule of mutually exclusive events, we're going to be talking about the general addition rule. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So that minus probability of A and B, that's what they do have in common. Remember, with mutually exclusive events, we didn't have to worry about that piece back there because they didn't have anything in common. But if they do have something in common, then you have to consider that piece. So let me show an example as to why you have to subtract what they have in common. Let's say greater than 2. All right, a single die is rolled. Find the probability of rolling an even number or landing an even number. I should say landing. Anyway, an even number or a number greater than 2. All right. So let's look at each event. You have even number and then number greater than 2. All right, so the sample space here is a single die. So the number of outcomes, possible outcomes is 6, 1 through 6. The number of even numbers, let's do it like this. That's 2, 4, 6. So the number of even numbers is 3. So the probability of getting an even number is 3 over 6. And once again, I'll reduce at the end. So the next event is a number greater than 2. Once again, our sample space is 6. I'll call this event G for greater than. So we got 3, 4, 5, 6. So we have 4 elements. This event, probability is 4 over 6. So before we go any further, everybody okay with our 2 initial events? All right, so we want to know the probability of getting either an even number or a number greater than 2. If I were to add those 2 numbers together, remember we talked about the probability or the addition rule for mutually exclusive events. If I were to add these 2 events together, probability of E or G, you don't have to copy this, just showing you something because I'm going to erase it anyway. That's 3, 6 plus 4, 6, which in this case will give you 7 over 6. And remember, the probability is supposed to be in between 0 and 1. The highest it can be is 1. So that gives me something greater than 1. So we know there's something going on here that we haven't considered. And what that is just that they have something in common. That even numbers, 4 and 6, numbers greater than 2, 4 and 6. So what's happening is that when you have events that have something in common, when you add their probabilities, whatever they have in common is being counted twice. So in this probability of 3 over 6, I'm counting 4 and 6. And in the probability of 4 over 6, I'm counting 4 and 6. So when I add my probabilities together, I'm counting it twice. So that's why I have to subtract what they have in common. So looking at the event of being even and greater than 2. Sample space once again is 6. When you're talking about being even and greater than 2, that's 4, 6. So we have two of those. That means the probability of getting a number that's even and greater than 6 would be 2 over 6. Not greater than 6, but greater than 2, excuse me. It would be 2 over 6. And now that we have all three pieces, we can find a probability getting an even number or a number greater than 2. Once again, we're doing the probability of E plus the probability of G minus the probability of E and G. So add up and subtract accordingly. So 3, 4, 7 minus 2 is 5. And that would be your probability. All right, questions before we look at the next one? All right, so I'll write the table in a second. But it says in the table, the data shows the results of an experiment conducted to test the effectiveness of a flu vaccine. If one person is selected from this population, what is the probability that the person was vaccinated or contracted the flu? Contracted the flu. So what's the probability that the person was vaccinated or contracted the flu? All right. All right. So, what is the probability that the person was vaccinated or contracted the flu? So, first of all, we recognize that our sample space right here is 490. That's the total of all the people. I didn't mention this. V, those who were vaccinated. F, contracted the flu. All right. So, our sample space is 490. That's our bottom number. So we want to know the probability of vaccination or contracting the flu. Vaccinated or contracted flu. Yeah. So what I need is probability of V plus the probability of F minus the probability of V and F. All right, total number of vaccinations is 219. So I'll write 219 over 490 plus the total number of those who contracted the flu, 97. That's 97 over 490 minus those who were vaccinated and contracted the flu, which is 21. 21 over 490. So questions on what we did, why we did it, anything we chose before we finish off the problem. All right. So that should be 295 over 490. And they gave the approximation of 0.602. And of course, WeatherSign will let you know which answer they want. That's it. All right. questions before we look at the complement? All right, so the complement of an event, it represents the opposite of the event. The complement will be all the elements in the sample space that are not in the event. And then we have e to this superscript c, represents the complement of event e. So if you had event G, then G with the superscript C would be the complement to event G. So you just that C right there is what represents the complement of your event. So just a mini example, if I have the sample space of 1, 2, 3, 4, 5, 6, if my event is 1, 2, 3, that means the complement of my event would be 4, 5, and 6. So all the elements in the sample space that are not in the event would be the complement of your event. All right, so the probability of the complement, so the different ways you could um, calculate or use the relationship. So the first one they give is the probability of your complement is equal to 1 minus the probability of your event. And then from there, you can use that to manipulate or find the other two. Probability of the event is 1 minus the complement. And then if you add both of your probabilities together, the probability of your event and the probability of your complement added together should equal to 1. All right, so the probability of tossing a sum of 11 on the toss of 2 dice is 1 over 18 or 1 out of 18. What is the probability of not tossing a sum of 11 on the toss of 2 dice? All right, so we want to know what's the probability of not tossing. So that's the complement. So you want to know what's the probability of the complement? That's going to be 1 minus the probability of the event that we have. Our event is 1 out of 18. They gave it to us. All right, if you're going to do the work by hand, 1 as a fraction needs to be 1 need to be converted to a fraction with a denominator of 18 in order to be able to subtract another fraction from it or this fraction from it. So 1 just turned to 18 over 18. And that 18 minus 1 is 17. 17 out of 18. So whatever that denominator is, then that 1 would turn into that over itself. That's still 1. So if that was 1 over 3, then that 1 would have turned into 3 over 3. All right, the probability that a person has type A blood is 34%. What is the probability that a person does not have type A blood? So once again, we're doing a complement. Probability that a person has is 34%. The probability that a person does not have is what we want to know. So we have the probability of the complement, just 1 minus the probability of the event. And don't forget, when you calculate, you're really supposed to convert that to a decimal, which is 0.34. And that should be 0.66. All right. Got one more example, and then we'll be good to go. All right, so we have a die is tossed 4 times. What is the probability that a 6 will show up at least once? All right, so let's establish our sample space first. If we have 6 times that I toss the die, not 6 times, excuse me, 4 times that I toss the die. So each one of these boxes represent the 4 times. First time, second time, third time, fourth time that I toss the die. We're talking about all possibilities. I have 6 ways in each case that I could get an outcome. You know, there's 6 faces on that die. So each time I roll it, I have 6 possible outcomes. So you will multiply those outcomes together. I believe there's 1296. Yep, 1296. 6 times 6 times 6 times 6 is 1296. So that's my bottom number. Total number of possible outcomes. All right, so the event that we want is at least 1/6. So what we can do here is it's easier to find the complement than it is to find just straight up at least 1/6. So the complement is no 6s. Yeah, don't need that. So when I talk about the complement, the number of my complement, the way I calculate that is to look at each die and eliminate the 6th option. In other words, what would be the number of just having 5 options? So I got 625 ways that I could have no 6s. And the probability of that is 625 over the 1296. Because there are 5 numbers that I know that are not 6, so that's where it came from. Just in case that helps. So in each case, there are 5 numbers that are not 6, so that's where we got that from. So now to calculate the probability of at least one 6, I can do 1 minus the probability of no 6. 1 minus 625 over the 1296. So that 1 would be 1296 over 1296. And that'll be 671. And once again, whoever signed will let you know which one they want. All right. Questions on anything that was said? All right. So that is it for 12. Let's see, chapter 12. Now I'll make sure to confirm that. But yeah, that's it for chapter 12. It's 12:1 through 12:4. So next class we'll be looking to review, making sure you guys are straight. I'll post that review shortly. So make sure you come to class, with questions. If you have them, I'll answer them. And that can be on anything, 'cause since everything's still open, you guys can still submit your work. Make sure you take advantage of that. Since I haven't closed anything off, that means you can pick up your grades from 5th week. All you have to do is make those submissions so that next time I look at it, come 10 week, I can give it a better report if you didn't get the report that you like. So anything before we close out? All right. So you guys have a great weekend. Be safe, and I will see you on Tuesday. Everybody take care.